I was curious about what would happen if I used natural language processing techniques to analyze ACARS messages. I don't know ACARS well, but I know that they can contain text information. And I wanted to try using text processing techniques that don't really know anything about ACARS messages to see if they gave interesting results. Kevin E gave me about 10,000 ACARS messages, and about 6,000 of those contained text content, of which there were about 3,500 unique texts. The rest were duplicates. And most of this looks like information that's meant to be read by machines. Some of this, meant to be read by machines, just happens to be encoded as text. Once in a while, you see something that looks like it was meant to be read by a human, but not much. I put each unique text into a semantic space using a technique similar to what GPT uses. It's a space with 1,536 dimensions, which doesn't really matter. And the important thing is just that it puts things that have similar meanings close together, even, as it turns out, ACARS message texts. This image crunches all 1,536 dimensions down into just 2. Each ACARS text is a dot, and each color is a cluster of ACARS messages that have similar meanings. And it does seem to have found some clusters of messages. We can look at the contents of each cluster. And without knowing anything about ACARS, it does seem like the messages in each cluster are similar. I'm guessing you can, deterministically classify and decode these messages if you know more about ACARS data formats, which I don't. But I wonder if doing an analysis like this might help give you a little more information about new, unknown formats. Like, I don't think people know how to decode every format of ACARS message. Maybe I'm wrong. The real potential here is for analyzing the messages that are meant to be read by humans. You could use a technique like this to classify the content of all those messages or detect unusual ones. And then this shows the result of using a slightly different algorithm to group messages. This one also tells you which ones didn't fit into any of the other groups, which could make it easier to detect anomalous messages. And then just for fun, here's the 3D representation of the 1,500 dimensional semantic space, and very clear clustering is visible. And you can kind of mouse over to see the first part of each message. And yeah, in the clusters, they look very similar. I'll do a search. Cue the dramatic music. Let's see. And it highlights the other closest points. So they're not always the closest in 3 dimensions, but they are the closest in, 1,500 dimensions. Shut down the APU. Your help is appreciated. So yeah, some of these are kind of similar. It didn't work perfectly. This is just a first experiment, but it seems promising. I think it would be especially interesting to try to select just the human readable messages and try to find clusters in those anomalies.